All right, so let's look at the second game from the big advanced linear set, which is the first game from PT31, and this is also a complex linear game. So in this game, they start off by telling us that there are four boys, Fred, Juan, Mark, and Paul, and there are three girls, Nita, Rachel, and Trisha. Okay? And these people are going to be assigned to lockers numbered 1 through 5. So we're going to put these people into lockers, and we're just going to draw the blanks for the lockers, as you would suspect. And we'll write down this is locker 1, this is locker 2, and so on. Okay? And while I'm writing this in, you want to start thinking about what is one thing that you notice about this game that is kind of different from the games that you have been doing previously, or a straight up linear game that you might come across. Uh, give you a second to think about it. Okay, so you may have noticed that there's 7 students, but there's only 5 lockers. And that's again why this is called an advanced linear game, because you know that there's going to be more than one student per locker, and also because how these students are arranged may depend on whether or not they're a boy or a girl. And it's really that second uh, characteristic that you have to pay attention to that makes this an advanced linear game or a complex linear game. Just the fact that there are uh, more variables than there are spaces doesn't make it a complex game, but it's the fact that you have to pay attention to that second characteristic about these people, that you can't just know their names, FJMP or NRT. You also need to know whether they are a boy or a girl, and you need to keep track of that. All right, so let's figure out how we're going to distribute these students into these lockers. Uh, each locker must be assigned to either 1 or 2 children, and each child must be assigned to exactly 1 locker. So the second part of that sentence says each child must be assigned to exactly 1 locker, meaning that everybody has to be included and nobody gets a space in more than 1 locker. So they each get to go in one space. The first part says that you're either going to have 1 or you're going to have 2 per locker. So they're giving us numerical information here. How do we make sense of this? Well, uh, did they tell us that every locker has to have a student in it? No. Okay. They just said, oh, yes, they did. I'm sorry. They said each locker must be assigned to either 1 or 2 children. Okay. So let's think about this over here just as a scratch paper. We're going to go like, okay, we don't know which locker this is, but every locker is going to get 1 student. So we'll be like, all right, we'll distribute these 5 students. We know that there's going to be 1 per locker, and then there are going to be 2 left over, right? So what we need to do is figure out how, given the rules, we can distribute these 2 extra people, right? And we want to distribute them over to here. Sorry. We want to distribute these 2 extra people over to here, right? Um, but the rule said that we're only allowed to put 2 people in a locker. So there isn't that much to think about, actually. We're like, we can take one of these guys and put him over here. Sorry, it shouldn't look like that. It should look like this. One of these guys and put him over here, and then take another guy, and he's going to have to go in a different locker because he couldn't go in the same one, because that would violate the rule that there is either 1 or 2 per locker. And so we know that this is going to be the distribution. Okay? There's no other way to do it. So it's going to be like a 2, 2, and then 1, 1, 1. Okay? That's how they're going to be distributed. Now, this is an unfixed distribution, meaning that we don't know, whether the 2 is going to be in locker 1 or whether the 2 is going to be in locker 5. We just know that there are going to be 2 lockers with 2 people in them, and that there are going to be 3 lockers with 1 person who uses each of those lockers. Okay? So that's what the first rule is all about, really. It's about figuring out this distribution. And so we've done that. And you'll notice that whenever you're able to figure out a distribution, it normally will help you a lot. And so keep an eye out for rules that allow you to do it. As you see more games that involve distributions, I'll continue to bring up those distributions and talk about what prompted us to think about doing a distribution in those cases, and hopefully over time you'll get better at finding them and using them. Okay, so let's look at the next rule. Each locker must be assigned to one girl. Each shared locker must be assigned to one boy and one girl. So these twos over here is what they're saying is that this, the two twos, the shared lockers, are going to have to be girl boy. Okay? That's actually going to be really important, but we don't know exactly how yet. So it says Juan must share a locker, but Rachel cannot share a locker. Okay? So let's make our rule box. All right, so these are the rules, and it says that Juan is definitely going to be in a shared locker, okay? So we could draw this by saying like this. Here's a locker, and we can put Juan inside of it, and we know that along with Juan, there's going to be one other person there. We don't know who, but we know that Juan is going to be in a shared locker, whereas Rachel, all right, she is going to be by herself. So we'll just put her in a locker by herself to indicate that she's just going to be she's going to be by her alone. Okay. Nita's locker cannot be adjacent to Trisha's locker. All right. So let's write that down here. Nita and Trish cannot be next to each other. So maybe the easiest way to do this is to say that this is not possible. Nita, Trish. Okay. They cannot be adjacent to each other. And also that the opposite way is also impossible, which means that it can't be Trish and Nita next to each other. Okay? There are a few different ways you could write this rule. If you have another way that you use consistently, that should be all right. But the basic idea, the basic drawing should look like this. You're saying that they cannot be horizontally next to each other. Okay? And Fred must be assigned to locker 3. So let's put Fred here in locker 3. And those are all of the rules. So now what we need to do is to think about how these rules are going to interact and try to make some deductions. So let's start with the idea of Juan. Okay, Juan is in a shared locker, but we don't know who's going to be in there with him. Okay, we do know that if there is a shared locker, then it's got to be girl-boy. So in this case, we have a shared locker, and we already have the boy who's going to be there. It's going to be Juan. So who else could go in there with Juan? We know it has to be a girl. Which girls are available to go in there? Well, the girls, again, are Nita, Rachel, and Trisha, but we see here that Rachel has to be by herself. So this is going to have to be either Nita or Trisha. Okay? So we put Nita or Trisha in there with Juan. So, and then we can use this and combine it with the rule that Nita and Trisha cannot be next to each other. So now we know that Juan actually can't be next to Nita or Trisha. He's going to be in the same locker as one of them. And then the other one, whichever one is not in the locker with Juan, can't be next to Juan because the locker with Juan will have to include either Nita or Trisha, and Nita and Trisha cannot be next to each other. Okay? So that actually should be a really useful thing for us. So let's think about who can be in the shared lockers. That's what we just started doing. But let's try to extend what we did here with Juan to the general case of the shared locker. Okay? There has to be a boy. So there's going to be another shared locker. And in that shared locker, it's going to be a boy. And then there's going to have to be a girl there. Right? But again, we know that Rachel can't be in a shared locker. So the girl, we don't know who the boy is going to be, okay? But we know that there's going to be another shared locker, and we know that in that locker, it's either going to be N or T, because there has to be a girl in the locker, and it can't be Rachel, so it has to be either Nita or Trisha. So the upshot is that both Nita and Trisha are going to be in shared lockers, and Rachel is going to be in a locker by herself. That, I think, is the most important deduction that you would be expected to make in this game, and it really should help us on a lot of the questions. Uh, you still want to give yourself another minute to think about whether you can figure anything else out, and you might not be able to, but you always want to give yourself a little bit of time, especially early on in your preparation, so that you can kind of get used to the process of making deductions instead of just always going right to the questions. You're not giving yourself a chance to learn how to set the game up properly and think ahead. So take a second. Um, and after we think about it for a second, it doesn't really look like there's all that much more we can do. But I do think that what the deduction we did make, which is that Nita and Trisha are both going to have to be in shared lockers, and one of them is going to be with Juan, and the other one is going to be with either Fred, Mark, or Paul, is going to be really important. Okay, so this is your basic setup, and from here we'll answer the questions, but we're going to do that in another video. So I'm going to pause. I'm going to stop this video, and then on the next video we'll start doing the questions, and that's just so that I'm able to upload them to YouTube without going over the time limit. Okay.